we will going to see one important numerical now. Now see, take out the main book. In main book, go to the part 2. In part 2, chapter 12, question 4. And it is December 2017 exam question 1. So now start reading this question. The question is on your screen. Give the heading of the question. Main book part 2 chapter 12 question 4. Try to read the question minimum 3 times. Please try to read the question minimum 3 times. We have already seen A part.
Yes, sir. Yes, sir. Yes, sir.
So now just read the B part.
Yes.
Now try to see the scenario here. We have what? A solid aluminum hemisphere. We have what? This is what? A solid aluminum hemisphere. What we
Yes.
have? Solid aluminum hemisphere whose dia is how much? 250 mm. So
Yes.
dia is 250 mm. So radius will become d by 2, 0.125 meter.
Yes.
Now try to understand the scenario, what they are asking us in the question. Understanding this question is very, very important to us. Now, what they are asking us, so this 250 mm diameter hemisphere raised its curved surface. This is what a curved surface of the hemisphere.
Yes.
So this curved surface, what is there? What they have given us? This curved surface, its curved surface on a rough plane. So here we have what? A rough plane is here.
Yes.
So this is what a rough plane, which is making how much angle?
15 degrees.
15 degree to the horizontal. So that is what we have shown, some enlarged view here. So this is what our hemisphere. See, try to understand this one. This is what our
Hemisphere.
hemisphere, and it is raised on its curved surface, raised on what? Inclined plane, and this inclined plane is making how much angle? 15 degree. So this line is what? What is the meaning of this line? Horizontal. So horizontal, and this inclined plane is making how much angle? 15 degree to the
15 degrees.
horizontal. That is what they have given till now. Now
Yes.
what they are asking us, calculate the force F. So here this is what a force F. This force F is visible to you.
Yes, sir. Yes, sir. Yes, sir.
So to calculate the force F needed on the edge of the hemisphere. So here on this edge, what we are doing? We are applying a some force F, and our target is what? We have to find out that force F needed on the edge of hemisphere as shown in figure question 1. Why they are saying figure question 1? Because in December 2017 exam it was a question 1. So generally whatever the name of the question, whatever the number of question, same will be the number of the figure.
Okay, sir. Okay.
So figure question was, that's why they have said figure
Question
figure question 1 to maintain the what?
to maintain the axis of the hemisphere in the vertical position.
In the what?
Vertical position.
Vertical position. You got this point?
Yes, sir.
To maintain the axis of the hemisphere in the what? Vertical position. So we have what? A density. Now our target is what? We have to find out. Now see this one. What our target is what? We have to find out this F to maintain the axis of the hemisphere in the vertical position. So this will be what? 1 minute. I am going to highlight this one. So this one I am going to highlight by yellow. This is visible to you?
Yes, sir. Yes, sir.
So this will be what? Axis of the hemisphere. So we have to find out the value of force F so that this axis will be what? It will be in vertical position. Means so in enlarged view it is now clearly visible. Now you may say, sir, this axis and point of contact is the same. See, this is a small view. That's why you may feel like that, oh, point of contact. But actually if you enlarge that one somewhere little bit away, sir, just
Yes,
observe.
sir. Yes.
So here if you observe, so here this is what? Our point of contact. This point is what? Our,
Point of contact.
and this point of contact we will say it as a point 1. We have a very important importance of this point. Now this is what? So now we will assume, so this is what? Our hemisphere. Our target is what? We have to find out the value of F so that this axis will, this is what? Axis of the hemisphere. This axis is visible to you.
Yes, sir. Yes, sir.
So our target is what? We have to find out the value of F. To maintain this axis is in what? To maintain this axis in
vertical direction.
to maintain this axis in what? Vertical position. That is what our target. You are getting my point? Now,
Yes, sir.
so now we are going to show different forces on this hemisphere. What is our target? Now what we are going to show? Different forces. So here now we have shown this is what? Yeah, that is acting on this edge. Now tell me what will be this distance? Tell me what will be this distance from here to here? From the axis to this distance, what will be this distance? Can you tell me?
Sir, 125.
Means radius.
Yes, sir. Radius. Diameter is 250. So radius is d by 2, which is 125. Which we are
Yes, correct. Very good. So this will be what? A radius. So capital R. So this will be what? A radius of the hemisphere. Any doubt in this discussion? So this
No.
will be what?
Radius.
Radius of the hemisphere. Any doubt in this discussion? You got my point? So this will be what? Radius of the hemisphere. Now try to see the scenario. Suppose we assume let m will be the mass of the, what we are going to assume, let m is equal to what? Mass of the
hemisphere.
let m is equal to what? Mass of the hemisphere. And try to understand the scenario. What we are going to assume? Let m is be the mass of the hemisphere. So now weight will be what? How weight will always act? Vertically downward. And somewhere here we will have a g. Somewhere here what we will have? G, capital G. What is meant by capital G? Few minutes before we have seen what is meant by capital G. Center of gravity. And through the center of gravity what will act? Weight will act vertically downward.
Yes.
So this will be weight. I am going to show it little bit dark. So this will be what? A weight. Generally we will show the forces by what? Generally we will show the forces by red pen and remaining things by blue pen and dimensions by green pen. That is generally we will follow terminologies generally. So this is what a weight, and weight how we denote? mg. mg. Mass into g will become our weight. That is what we have seen. If you remember our weight discussion. If you remember our weight discussion, weight means what? M into g.
Yes, sir.
My mass in kilogram, g stand for acceleration due to gravity. So what we are going to show? So weight will be what?
mg.
mg. Any doubt in this discussion?
No, sir. No, sir.
So this is what? Weight mg. Try to understand the next point here. Now what I am going to do, what we are going to do from this center of this circle, this is what? A center, this point.
Yes, sir. Yes, sir. Yes.
From this point what we are going to do? We are going to draw one dotted line. Just observe this one. We are going to make this one as a dotted. Now this is what? The speciality. This plane is what? This plane. 1 minute. This plane is what? A tangent to the circle. This plane is what? A tangent to the circle. And this line from the center will be what? Will become what? A perpendicular to this line. Always remember this one. This is a basic geometry concept. This line, this dotted line is always
Perpendicular to the plane.
Perpendicular to the plane. Means plane is like a tangent to the circle.
Yes, sir.
So here, so this line is what? A perpendicular. And how to show the perpendicular symbol? 1 minute, I will use black color pen. So this symbol will be what? This symbol. This symbol denote what? Perpendicular. So this is what? 90 degree. So this line and this is what? 90 degree. Now try to understand these things carefully. What will be this angle? Tell me. 1 minute. What will be this angle? Can you tell me? This angle? Now
75.
correct, 75 degree. And how we got it 75 degree? Try to understand the scenario. See, this is what? This triangle. I am going to highlight this one so that you will get a. See, this triangle is what?
Right angle triangle.
Right angle triangle. This triangle is what? Right angle triangle. Now, so this triangle is what? Right angle triangle. We are considering this triangle. So for this triangle, So for this triangle, what will be the scenario? This angle is what? 90 degree.
Yes, sir.
So if, and we have studied sum of, in our basic standards in our junior classes, what we studied, sum of all angles of triangle is what? 180 degree. So this angle summation is what, sir? 180 degree, sir.
Yes, yes.
So now if this summation is, now if one angle is 90 degree, then what will be the summation of remaining two? 90 degree.
Yes, sir. 90 degree.
So this got, we got 15. So then for the summation of 90 degree, this must be what? How much?
75.
If this is 75, so we got this angle is what? 75 degree. If this angle is 75 degree, automatically this angle will become what? 1 minute, I will show properly. Then this angle will become what? This angle will become what? Tell me. This angle will become also 75 degree, opposite angle. Opposite to each other, sir. Means suppose
Yes.
this is what? So these two angles must be what? Opposite to each other. So they must be what? Sum. This is also we studied on in our basic standard.
Yes, yes, sir.
So this is 75 degree. Now this is 75 degree. Now tell me, what will be this angle? That I
That
have.
angle will be 15 degree.
So see, sum of these three triangle, this sum of these two
90
must
degree.
90 degree, because this, for this triangle, this one
Mm.
180 degree. If this is 90 degree, then remaining two will also 90 degree. So if
Yes,
75,
yes.
then this
Yes.
will be what?
15 degree.
15 degree. Now try to understand the scenario here. From this point, what we are going to do? We are going to draw one dotted line. From this point, what we are going to do? We are going to draw one dotted line. Just a vertical line. This dotted line is a vertical line. From here to here, we are going to assume this distance as a what? X. What we are going to assume?
Yes.
X. Try to see the scenario. This is what? X. If this is X, then what this distance will become? Tell me. What
R minus X.
this distance will become what? R minus X.
Yes.
Now tell me, what this will become? This length, this one. I am going to highlight in, suppose I am going to highlight in yellow. What this dotted, this one will become this one? Tell me. This one will become what? This length will become what for this one that I have highlighted? This will become what? Tell me. Radius.
Length will be radius and a radius.
Radius of this hemisphere. So
Yes,
this
yes.
will become what? A radius R.
Yes.
Then what will be this angle? What will be this angle?
That angle will be
What will be this angle?
75, sir.
See, this always remember. Suppose these two sides. Whatever the angle on this side, if those two sides are parallel, opposite side. If this is 15 degree, by default, this will also be what?
15 degree.
15 degree. You got this point now?
Yes, sir.
So this angle will become what? 15 degree. Now you got it, 15 degree. Now we are nearer to our answer. We are what now? Nearer to our answer.
Okay, sir.
Now this, you got my point? Now any doubt in this drawing? You got this figure?
Yes.
Before going further, please draw this figure properly, and then we will see how to manage all the things further.
Okay, sir.
Please draw this figure properly. So now what we are going to assume, let m will be the what? Mass of the hemisphere
Yes.
in kilogram. Now what
Yes.
they have given us? Density. Density of aluminum they have given us 2800 kg per meter cube.
Yes.
Density is how much? 2800 kg per meter cube. Now try to see the next point here. They have given us a volume here. How much volume they have given us? 4 by 3 pi r cube. So now we know mass will be equal to what? Volume into density. Because density means what? Volume by mass, na? Sorry,
Yes,
not
sir.
volume by mass, mass by volume. Density is
mass by
what?
volume.
Mass by
kg
volume.
per meter, kg per meter.
So density is what? Mass by volume, kg per meter cube, correct? So then
Yes,
mass will become what? Volume into density.
yes,
Now
sir.
what will be the volume of hemisphere? What will be the relation of volume of the hemisphere? What relation we can
4 by
say?
4 by 3 pi r cube. Hemisphere.
Hemisphere. What will see? Here in the question also never write down the relation blindly. Here in the numerical they have given us a relation of a
Sphere.
sphere. But in the question what they have given us?
Hemisphere.
Hemisphere. So then what will be the volume of hemisphere? What will be the relation that one?
Mm,
1 by 2 half
half
4
half into 4 by 3.
pi r cube
Yes, sir. Yes, sir.
into density. So in this way
Hmm.
we will get a mass. So half into 4 by 3 pi r is how much? 0.125 cube. Density is how much? 2800. So please all the values in your calculator. So how much value you are getting?
One second. So 11.453. So
11 point. So how much mass we are getting? 11.4537 kg. So this is hot of mass we are getting. 11.4537 kg of the mass we are getting. Now what is our next target? What we have to do? Try to see the scenario. 11.4537 kg of the mass we are getting. Now the next thing will be what? Observe the next thing. Now how to get this x? How to get this x? So for that one, observe this triangle. This triangle. So this
yes, sir.
for with respect to this 15 degree, this x will be what? Opposite. With respect to this 15 degree, x will be opposite. This
Yes,
r is what? For this triangle. This triangle. Observe this one. This triangle.
sir.
For this triangle, r is what? This
R is well adjacent.
r is what? Adjacent.
Yes, sir.
R is
Adjacent.
what? Adjacent.
Yes, sir.
So opposite by adjacent.
Adjacent. Yes, sir.
Opposite by adjacent will be what? Opposite by
Adjacent will be 10.
opposite by adjacent. Sorry, opposite by hypotenuse. This is hypotenuse, na? This is not a adjacent.
For the 15 degree, sir, for the 15 degree, it will be.
Sir, for 15 degree, this will become adjacent, na? Opposite to
Okay.
90 degree. This is hypotenuse, na?
Yes, 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 yes.
So this is not adjacent.
Understood, understood.
So then what we will say? So what we can say? Try to see the scenario. So opposite by hypotenuse. What is the relation between opposite and hypotenuse?
Opposite by hypotenuse is sine.
Sine 15. So sine 15 degree will be equal to what?
Sine 15 degree is equal to opposite by adjacent opposite.
Opposite. X by what? X by r.
Yes, sir, x by r.
So x will become what? R into sine 15. R
Yes,
is
sir.
how much? 0.125 multiplied by sine of 15. So how much value of x we are getting? Try to do the calculation.
0.0323.
0.032
3.
meter. So in this way what we got it? We got the
3.
value of x.
Yes, sir.
Any doubt in this discussion?
No, sir.
So now before going further, please write down all this discussion.
Yes,
Now,
sir. Yes.
now tell me, this object is it in equilibrium? This sphere is it in equilibrium?
No, sir.
No.
No, sir, it is not in equilibrium, sir.
How does you come to know that it is not in equilibrium? How does
Because
you?
it is lifted in the angle of 15 degrees, so it will not stay. It is a circular object.
Read the question. What they are asking us? What they are asking us? We have to calculate the value of force F needed
Yes,
on the edge of the hemisphere to maintain the axis in a
the
vertical
hemisphere
position.
in the vertical position.
So if you want to maintain the axis vertical position, then this sphere, is it a stationary or moving? If you want to maintain this axis vertical, then this
Hmm.
sphere stationary or moving?
Mm,
Stationary or moving? Out of this, which option is correct?
sir, it needs to be stationary.
It needs to be stationary. If any object is stationary, then what we have studied is in equilibrium. If you go to the equilibrium scenario, if you remember our discussion,
Hmm.
if any object is stationary, then that object is said to be in what?
Equilibrium position.
Equilibrium. So this hemisphere, in this question, this hemisphere, is it in equilibrium or not?
Yes, sir. Equilibrium.
This hemisphere is in what?
The hemisphere is in stationary and it is in equilibrium.
So that's why it is in equilibrium. And if any object is in equilibrium, then it satisfies equilibrium equation. And what is the equilibrium equation? We will say summation of moment about any point, and we will take a summation of moment about which point we are going to take. We are going to take a summation of moment about point O equal to 0, because object is in equilibrium, and taking clockwise as what? Positive.
Yes.
Why moment equilibrium is 0? Why summation of moment about point O is equal to 0? Why 0?
Uh,
Because
summation.
because this sphere is stationary, and if any object is stationary, then we can say that object is in what? Equilibrium. You got the meaning of equilibrium?
Yes, sir. Yes, sir.
Any doubt in this equilibrium concept?
No, sir. No, sir. It is stationary. It is stationary, so it is zero, sir.
So if any object is what? Stationary, then we can say that object is in what?
Equilibrium.
Equilibrium. You got my point now?
Yes, sir. Yes, sir. But this moment, the summation of the moment, it is zero oblique, sir.
Yes, it is a 0 now. That's why, means as it is stationary, then summation of moment must be 0, sir.
Okay, sir. Okay, sir. Okay, sir.
So if any object is in equilibrium, then there is summation, that net resultant moment will be what? 0, na?
Yes, sir. Yes, sir. Yes, sir.
Now here how many forces here? We have two forces. One force is F, another force is what? Weight mg.
Yes, sir.
So here we have two forces. Force F and weight
And
mg.
weight mg.
Weight mg. Now try to see the scenario here. Observe the things. Now we are going to take a moment about which point? We are going to take a moment about O point. Now moment means what? Force into perpendicular distance due to F about point O, clockwise moment or anti-clockwise moment. Due to this force F about point O, clockwise
Yes,
moment or,
clockwise. It will be clockwise.
and what will be the perpendicular distance? What will be the distance of F with respect to point O?
With respect to the point or distance of.
Perpendicular distance means extend this line further and try to
Yes.
measure this distance. What is that distance will be?
The r minus x.
R minus x, correct. So what we will take? Effect of F is what? Clockwise. Clockwise means positive, and perpendicular distance will be what? R minus x. Then we will have another force. What is our another force? Weight mg.
Yes.
So for weight mg, what will be the clockwise effect about point O and anti-clockwise? So with respect to, just imagine this is what our point O and this is what mg. So what will be the turning effect? Like
Turning
this,
effect will be anti-clockwise.
anti-clockwise. So effect,
Yes.
turning effect will be what? Anti-clockwise. So then perpendicular distance will be how much? Perpendicular distance how much? Of mg with
X.
x. Perpendicular distance will be x. So then
Yes.
minus mg into what? X. And that
Yes.
will be equal to what? 0. You got my point? So their net summation will be equal to what? 0. Now then we can say F into r minus x is equal to what? Mg into x.
Yes.
So then F will be equal to what? Mg into
Into
x
x by,
r minus x.
yeah.
And we already calculated mass 11.4537. So mass is what? 11.4537. G is what? 9.81. X also we calculated 0.0323. And R is how much? 0.125. X is what? 0.0323. So please put all the values in your calculator, and we will get the value of force F, which is needed on the edge of hemisphere to maintain the axis what? Vertical.
Thirty-nine point one five zero, sir.
39.1505
150.
unit.
Yes. Yes, sir.
Force unit will be what? Newton.
Indian, sir.
And how to identify answer is correct? So we have a written answer here also.
Okay,
So
sir.
39.15. So it is matching approximately correctly.
Yes, sir. Yes.
Any doubt in this discussion?
Sir, this discussion, this summation of the moment is zero. That
Huh.
is by the law. So after that, we are writing that f into r minus x.
Huh.
F into r minus x. That is by the, it is in clockwise direction. The
Huh.
force acting on its clockwise direction.
So
So we are taking,
we consider clockwise as a positive, na? That's why we have taken this one positive.
yes, sir. So basically that is like force into distance.
Force into distance, sir. Force into perpendicular distance.
Force into perpendicular. Oh, हम लोग force into perpendicular distance always.
We have seen in relation. See the moment relation I have given to you in last lecture.
Yes, sir. Yes, sir. Yes, sir. Force into perpendicular distance.
Force into perpendicular distance. See.
Yes, sir. Yes, sir. Yes, sir. I have taken, sir. Taken.
This one. Force
So
into perpendicular distance.
okay, sir. So we are writing, yeah, f into perpendicular distance r minus x, and okay, after that this, the center point is O. This load is acting on an anti-clockwise direction.
Then wait. So with respect to weight,
So
anti-clockwise and perpendicular distance is what? X.
yes, yes.
And anti-clockwise we will consider as a negative, sir.
Is mg minus x, mg into x, which is equal to zero. So this equal to zero is as per the law that the moment
Means
is zero.
because what? Equilibrium. See, now tell me this system is what? It is a coplanar or non-coplanar? Tell me first of all. Coplanar or non-coplanar?
It is coplanar, sir.
It is a coplanar because all the forces is in the plane of what? Plane of the screen. It is
Yes,
a concurrent or non-concurrent?
it is a concurrent, sir.
How does you come to know that it is concurrent? Is these two forces meet each other? This F
No,
and
sir.
mg?
No, sir. No, sir. No, sir. Different points. Inconcurrent.
Non-concurrent?
Yes, sir. Yes, sir.
So these two forces, coplanar, non-concurrent, and if any
Yes.
coplanar non-concurrent force system is in equilibrium, if any coplanar non-concurrent force system is in equilibrium, then this satisfy these three equilibrium equation.
Yes, sir. Yes, sir. Yes, sir.
So means what? If coplanar non-concurrent three forces, if coplanar non-concurrent force system is in equilibrium, then this satisfy following equilibrium equation, and out of that three, this is one equilibrium equation. Observe this one.
Yes, sir. Yes, sir.
Summation of moment about any point, and which any point we have selected here.
Understood, sir. Understood, sir.
You got my point now?
Yes, sir. Yes, sir. Yes, sir.
And how does we come to know that this sphere is in equilibrium? How does you come to know that this sphere is in equilibrium? Tell me.
This sphere is in equilibrium because it is stationary.
As it is stationary, we come to know that it is in equilibrium, and if any object is in equilibrium, then it satisfies equilibrium equation. And for
Yes.
coplanar non-concurrent three force system, what are the equilibrium conditions? These three are equilibrium equations.
Yes, sir. Yes.
So before going further, please write down this discussion.
Okay, sir. लिख दिया सर।
अभी हम क्या करते हैं सर? अभी हम ब्रेक पे जाते हैं, 15 मिनट का ब्रेक लेते हैं। स्टोरी समझ में आ गई ना सर अभी की आपको?
समझ गया समझ सर। एक बार ऊपर तो आंसर का स्टार्टिंग डायग्राम को ऊपर थोड़ा लिखा है ना सर, जो फोर्स जो क्वेश्चन को थोड़ा नीचे से थोड़ा नीचे। यस सर, यस सर, यस सर।
ये लिखा नहीं क्या आपने?
नहीं सर, ये D2 सब लिखा नहीं सर।
हाँ हाँ, ये लिखा नहीं था शुरुआत में।
यस सर, यस।
Just write down this discussion. That is what our target in B part.
यस सर।